Alrighty guys, I wanted to start with a quick warm-up. We're going to be using radicals in the lesson on special right triangles, so I wanted to go through simplify a few different radicals, and hopefully we kind of remember how to approach all of these. So first one is just going to just simplify the square root of 72. We're just going to create a factor tree. So I'm going to go off to the side somewhere, let's go way out here, and I'm going to write down all the factors of 72. So we've got 8 times 7, no, that's 56. How about 8 times 9? 8 is 4 times 2, and then 4 is 2 times 2, and then 9 is 3 times 3. So we look for our pairs. I see a pair of 2's, I see a pair of 3's, and then this 2 does not have any pairs. So we know that for every pair, right, we can square root it. So that becomes a 2. Remember, these are all square roots. Right? Everything is square roots because 72 is a square root. And then a pair for the 3's comes out, and then whatever does not have a pair is going to stay on the inside. So this is going to end up being 6 radical 2. Now for number 2, this one is really nice because all we have to do here is we're just going to divide the two whole numbers. So the common misconception here is to want to divide the square root of 6 by the 3 as well, but you can't do that because the 6 is inside of a square root. So this is going to just end up being 4 radical 6. And then for number 3, we saw this at closer to the beginning of the year, but this has a radical in the denominator, which we can never have. So what we need to do to get rid of the radicals, we're going to do something called rationalizing the denominator. So we're going to multiply the top and the bottom by radical 3. Right? And what that's going to do is, if you look at the denominator, you are going to cancel out the radicals, right? Because radical 3 times radical 3 is radical 9, and the square root of 9 is just 3. And then I'm going to end up with, on the top, I'm just going to multiply the top out. 4 times radical 3 is just 4 radical 3. And there's nothing else we can simplify. So I'm done. If we look at the last one, here we're just going to multiply and simplify. So there's two ways you can do this. If you want to multiply them together, you can. All right, so we can do 3 times. Remember, radicals can multiply with radicals. So radical 3 times radical 12 is radical 36. Oh, that's kind of nice because radical 36 is just going to break up to 6 times 6. There's a pair. So I end up with 3 times 6, which gives me 18. So on the second half of this lesson, we're going to focus on something called special right triangles. So in this lesson, we're going to be able to identify the side lengths of a 45-45-90 triangle and a 30-60-90 right triangle. And you're going to want to be able to apply those side length measurements to solve for missing side lengths. So the first thing we need to do is we need to be able to derive the side lengths for a 45-45-90 triangle. So we're going to start with a quick task. We're going to find the diagonal length, so in this case DB, of each of the squares below. And we're going to write our solutions in simplest radical form. So let's go ahead and let's look at this first one. So first thing I need to identify is that this is a square, right? So this side is 1, then that means that this side is also going to be 1. We know this side is going to be 1, and we also know this side is going to be 1. But in this case, I'm only going to be looking at this triangle right here. I'm only looking at this half of the square. So notice that this is a right triangle, right? Every square has 4 right angles. And I'm going to give you guys a second to see if you can figure out what the measurement of these two angles are going to be. So these are going to be 45 degrees. Right, 45 degrees for each of these, right? It's half of 90. So since this diagonal cuts that measure in half, we know those have to be 45. Now let's go ahead and find the measurement of the hypotenuse here. So in this case, my hypotenuse length is going to be Well, we can use a Pythagorean theorem in order to figure that out, right? We can do 1 squared plus 1 squared equals whatever that measurement is squared. So this is 1 plus 1, and then I'm going to get 2 after adding those up. Then I'm going to square root each side to solve for c. So I end up with c equaling the square root of 2. So now in this case, this measurement right here is now equal to the square root of 2. So let's see what we get in the other triangle. Let's see if we can find some sort of pattern. So the triangle we're going to make out of this square, we're going to start with just looking at just this piece right here, right? We know this is a square, so we know that all the side lengths have to be 2. And now again, we can use the Pythagorean theorem to find the measure of the hypotenuse because we know this is a 90, and we know these two angles have to be 45 degrees. So the triangle has the exact same angle measurements, and let's see what happens when we find the hypotenuse. So let's go off to the side, and this hypotenuse measure is going to be 2 squared plus 2 squared equals that hypotenuse measure. This will be 4 plus 4. Let's add those up. When we square root it, we're going to have to break it up to its pairs, and we end up with 2 radical 2. So now my hypotenuse is now 2 radical 2. So what would you do now if I gave you a square? What if I gave you a square with the side length of 3 now? Right? What if I gave you a square, but this time I said it had a side length of 3? How would you find that diagonal length? What would you do to find that diagonal length from there to there? Well, we could do this really quickly. If we notice a pattern here, notice how all the lengths of the hypotenuse have a radical 2, right? This one is radical 2, this one is 2 radical 2, and this one is going to end up being 3 radical 2. Notice how whatever the side length is going to go in front, and then all we do is just add that radical 2. So now we end up with we can end up with a formula for our right triangle here. So instead of 3, let's put instead of a 3, let's put an x instead. Let me redo that. Let's put an x instead of a 3. So now I get x, and then x radical 2. So now this is going to be my 45 degree angle, this is my 90, and then this is going to be my other 45. And this is the formula that we're going to want. And we'll come back to it and revisit it in just a second.